I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. We're on haloalkanes and reactions of haloalkanes, which are the halogenoalkanes and the reactions of halogenoalkanes. So before us, a typical A-level chemistry question on haloalkanes. When bromoethane reacts with hot ethanolic sodium hydroxide, a colorless gas is formed. This gas decolorizes aqueous bromine water. What is the colorless gas? So this elimination reaction of halogenoalkanes, when ethanolic solution of sodium hydroxide reacts with halogenoalkane, an alkane will be produced. So which is elimination. Elimination of what? Hydrogen halide, you get an alkane. Elimination of hydrogen halide from bromoethane, you get what? An alkane. So this is bromoethane, which is CH3. CH3, CH2, Br plus ethanolic solution of sodium hydroxide, alcohol, ethanolic solution of sodium hydroxide, alcoholic solution of sodium hydroxide. So you get what? You are eliminating hydrogen bromide, HBr. So in between the carbon atom, we remove the hydrogen and the bromine atom. That's where a double bond will appear. So remove hydrogen here, we'll have CH2. Double bond, you remove bromine here, you have what? CH2. So you produce what? Ethane. Ethane. And just to confirm that the answer is the gas is ethane, it was stated that this gas decolorizes bromine water. So it's unsaturated hydrocarbon that decolorizes what? Bromine water. So the correct answer to this question is what? C, which is what? Ethane. Ethane is the correct answer. So it's as simple as what? A, B, C. So this elimination what? Reaction of what? The halogenoalkane to produce alkane, and alkane decolorizes what? Bromine water. So I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures, still on haloalkanes and reactions of the haloalkanes, which are the halogenoalkanes and reactions of the halogenoalkanes. So before us, a typical chemistry A-level question on haloalkanes and reactions of haloalkanes, which are also known as halogenoalkanes, which will describe the solvent used and the type of reaction occurring when bromoethane reacts with sodium hydroxide to form ethane. So this elimination reaction, reactions of the halogenoalkane with ethanolic solution of sodium hydroxide. So you get an alkane, you get water and what? Sodium bromide. So we have to look at the solvent and the type of reaction. So the correct answer to this question, the solvent should be ethanol. The solvent should be ethanol. Why the type of reaction is what? Elimination reaction. So the correct answer to this question is what? A. So it's as simple as what? A, B, C. B, the wrong answer, because it's not substitution. The solvent is correct, but substitution, the type of reaction is not substitution. So B is not correct. Then C. C, if the solvent is water, water, you are going to get an alcohol, and the reaction will be what? Nucleophilic substitution. So C is wrong. D is also wrong because the solvent is water, which will give you alcohol, and the reaction is substitution reaction. So D is the wrong answer. So the correct answer is what? A. So it's as simple as what? A, B, C. Attempt as many questions as possible, and feel free to reach out to me if you encounter any challenge or any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Feel free to reach out to me. Thank you very much. I'm Mr. Joseph, your chemistry teacher, still on haloalkanes and reactions of the haloalkanes, which are known as halogenoalkanes, and reactions of the halogenoalkanes. Now, before us, a typical chemistry A-level question on haloalkanes and reactions of haloalkanes. Which statement describe what happens when 2-chloro-2-methyl-propane is one with sodium hydroxide, aqueous solution of sodium hydroxide? Now, the first thing to do is to identify the type of the halogenoalkane that 2-chloro-2-methyl-propane is. You know, we have three types of halogenoalkane. We have the primary halogenoalkane, secondary halogenoalkane, and tertiary what? Halogenoalkane. Then you can tell the correct answer to this question. Now let's draw the structure for what? 2-chloro-2-methyl-propane. So this is 2-chloro, 2-methyl. Then you have CH3. Then you have CH3. So 1, 2, 3. So this is 2-chloro, 2-methyl-propane. So it's a tertiary halogenoalkane. In a tertiary halogenoalkane, the carbon atom bonded to the halogen is bonded to 3 alkyl groups, which are CH3, and no hydrogen atom. So which statement describe what happens when 2-chloro, 2-methylpropane is one with so aqueous sodium hydroxide? A. This secondary halogenoalkane reacts by a mixture of an SN1 and SN2 mechanism. So A is wrong because 2-chloro, 2-methylpropane is a tertiary halogenoalkane, not a secondary halogenoalkane. Then B, this secondary halogenoalkane reacts only by an SN2 mechanism. Yeah, B is also wrong because 2-chloro, 2-methylpropane is a secondary halogenoalkane and it reacts by SN1 mechanism. Then let's look at C. This is tertiary halogenoalkane, react mostly by SN1 mechanism. Yes, C is the correct answer. C is the correct answer to this question. Yeah, 2-chloro, 2-methylpropane is a tertiary halogenoalkane and react mostly by what? SN1 mechanism. SN1 means substitution nucleophilic unimolecular. Unimolecular means that the rate of reaction depends on the concentration of the halogenoalkane and not on the nucleophile. Now let's look at D. This tertiary halogenoalkane does not react with hydroxide ion under this condition. So D is what? D is wrong. So the correct answer to this question is what? C. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me and I'll be there for you. Thank you very much. I'm Mr. Joseph, your chemistry teacher, still on haloalkanes and reactions of the haloalkanes, otherwise known as halogenoalkanes, and reactions of the halogenoalkanes. Before us, a typical chemistry A-level questions on haloalkanes and reactions of the haloalkanes. Now, which type of reaction happens during the hydrolysis of 2-bromopropane? When we talk about hydrolysis, it has to do with the breaking down of substance using water. And water is a nucleophile. So when they react with what? A halogenoalkane, to undergo what? Nucleophilic substitution to produce an alcohol. So the correct answer to this question is D. It's as simple as ABC is D. Halogenoalkanes also undergo what? The major reactions of the halogenoalkanes is nucleophilic substitution. So hydrolysis of 2-bromopropane, which is halogenoalkane, if you undergo what? You undergo hydrolysis since it's reacting with water and water is a nucleophile. So the answer to this question is what? D, which is what? Nucleophilic substitution. A is wrong, electrophilic addition. Halogenoalkane doesn't undergo electrophilic addition. B is wrong, which is free radical substitution. Is the alkanes that undergo free radical substitution. Then C is wrong, which is nucleophilic addition. Nucleophilic addition is the aldehydes and the ketones that undergo nucleophilic addition. So the correct answer to this question is what? D. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter any difficulty. I'm always there for you and I'll be there for you. I'm Mr. Joseph, your chemistry teacher. Thank you very much. I'm Mr. Joseph, your chemistry teacher, still on haloalkanes and reactions of the haloalkanes, which are the halogenoalkanes, and reactions of the halogenoalkanes. Now, before us, a typical chemistry A-level question on halogenoalkanes and reactions of the halogenoalkanes. Now, which reagents and condition would result in the formation of butane nitride, which is CH3, CH2, CH2CN? Which reagents and condition will result in the formation of what? Butane nitride. So if you look at A, we're going to consider the option 1-bromobutane heated under pressure with ammonia and ethanol. So A is wrong. A is not the answer. A will produce an amine. Then let's look at B. 1-bromopropane heated with potassium cyanide in ethanol. I think B is the correct answer because 1-bromopropane heated with ethanol solution of potassium cyanide will give you what? Butane nitride, because the nitride group, which is CN, contain an extra carbon. Even though you are starting with 1-bromo, what? You are starting with 1-bromopropane. So the correct answer to this question is B. 1-bromopropane heated with potassium cyanide in ethanol. If you look at C, C is wrong. Propanol heated with hydrogen cyanide in the presence of potassium cyanide. C is not the correct answer. If you look at the propanol heated with hydrogen cyanide in the presence of cyanide ion. So also D is not the answer because D are going to produce a hydroxyl nitride. So the correct answer to this question is what? B. So it's as simple as ABC. Attempt as many questions as possible and feel free to reach out to me if you encounter with any challenge or any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me. Thank you very much. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.